Hello and welcome to limits of difference quotients. So the idea, the difference quotient which is f of x plus h minus f of x all over h, measures the slope or calculates the slope of the secant line. Between the points x, f of x, and x plus h, f of x plus h. So in terms of the graph, we have some function, and we have our points x and x plus h, which are h apart. And then we take the points on f, and we're drawing the line between them, and the difference quotient calculates the slope of this line. Right? And now we're going to look at what happens as h goes to 0. So if we let h go to 0, then the 2 points get closer and closer together. And the secant line approaches what is known as the tangent line. So on the graph I've drawn here, the tangent line is the line that just barely touches at the point, at the value x, f of x. This is our tangent line. You can see as we let points get closer and closer in, our secant lines get closer and closer to the tangent line. So we're calculating the slope of these secant lines as we let h go to 0. It winds up essentially calculating the slope of the tangent line. All right. So the limit of the difference quotient is the limit as h goes to 0 of f of x plus h minus f of x all over h. This limit calculates the slope of the tangent line. To f at x. So let's go ahead and do an example where we actually calculate the slope of the tangent line using this difference quotient. So let's go ahead and find the limit as h goes to 0 of f of 3 plus h minus f of 3 all over h. So first thing I would do is I would notice that we need to find f of 3 plus h. And we also need to find f of 3. So let's do f of 3 plus h first. So f of 3 plus h. F says that whatever it is we're trying to plug in, we first square, and then to that we add 2 times the thing we're plugging in. So f of 3 plus h, we're going to do that inside squared, and then add 2 times our input. So that input in this case is 3 plus h. So we have a 3 plus h, the entire thing squared. Then we have a 2 plus 2 times 3 plus h. For our f of 3, our input is 3. We are just looking at 3 squared plus 2 times 3. 3 plus h squared, going back to our f of 3 plus h, we are looking at 3 plus h times 3 plus h. Then we are adding our plus 2 times 3 plus h. If we FOIL out 3 plus h times 3 plus h, we have a 3 times 3, then a 3 times h, an h times 3, and an h times h. That gives us 9 plus 3h plus another 3h plus h squared. For the second component, we have a plus 2 times 3 plus h. That 2 distributes to both the 3 and the h. We are looking at a plus 6 plus 2h. From here, all that remains is combining like terms. We have a plus 3h, a plus 3h, and a plus 2h, all of which can be combined. We also have a plus 9 and a plus 6, which can be combined. So we are looking at h squared, plus we have 3h plus 3h is 6h, plus 2h is 8h, and then plus 9 plus 6 is plus 15. So this is our f of 3 plus h. That's the first component of our difference quotient. Now going back to our f of 3, we are simply looking at f of 3 is 9 plus 6, better known as 15. This is the second component of our difference quotient. Now let's go ahead and put it all together. So we were looking at the limit as h goes to 0 of f of 3 plus h minus f of 3 all over h. We can now go ahead and plug in. This is equivalent to the limit as h goes to 0 of that f of 3 plus h is just h squared plus 8h plus 15. F of 3 is just 15, so we subtract off 15. And then we're dividing by h. This becomes the limit as h goes to 0 of, up top, we have h squared plus 8h. Plus 15 minus 15 goes to 0. And down below, we just have h. This is a 0 over 0 situation. If we plug in h equals 0, we have 0 squared plus 0 over 0. So we can go ahead and try to simplify. We can factor an h out of that numerator. We are looking at the limit as h goes to 0 of h times h plus 8 all over h. That is the same as the limit as h goes to 0 of h plus 8 all over 1, or just h plus 8. And as h goes to 0, we simply get 8. So this is our limit as h goes to 0 of f of 3 plus h minus f of 3 all over h is simply equal to 8. Or in other words, the tangent line to f at x equals 3 has slope 8. So as a general rule of thumb, anytime when we do limits of difference quotients with polynomials involved, when we reach this last step where we actually take the limit, you should be able to factor an h out of your numerator and then cancel the h to simplify. It gets a little more complicated if we're working with something other than polynomials. But with polynomials, the simplification will always work. All right, that is the difference quotient.